Hello, statistics class. Dr. Jen here. I'm going to do a video review of how to do an ANCOVA in this. This is based on the in-class lab of ANCOVA that was updated in 2024. I am on SPSS version 29 right now. Okay. So we have a data set that can be found for our lab called data set for in-class lab 5. It should be found within the course. You can download that within our Canvas system, and you're going to be able to examine the effects of two independent variables on a dependent variable with a covariate. So let's look at that. I'm going to just kind of get to know this data set a little bit. If you remember this little cool A1 button, if you're working from your own computer, you can see that when you press it, you can see some things. So right here, we have type of treatment. And I double clicked on that and went over so I could just kind of see type of treatment. Sorry, it became very large. I don't want it that large. I want everything a little smaller. So type of treatment that we have here are a couple of them. When I click, it looks like we've got ACT and DBT, right? So you guys are well aware of that. Two different types of therapy. And then we have 4 different stages of change that the participants would be put into one of these 4 because it's a categorical variable. And so they're either pre-contemplation, contemplation, preparation, or action. And if you don't know anything about stage of change, you can just Google that or read Wikipedia or something, and it'll explain it. But everybody who comes into therapy is in a kind of a different stage of change. Then we're going to have a score on a depression measure and a score on a stress measure. So those are our 2 continuous variables. So kind of looking at that. And now I'm back to data view over here. Okay. So the first thing is to have the research questions. And you want to always remember when you have a factorial, ANOVA, or ANCOVA, then you are going to have actually multiple hypotheses. In this case, we have 2 independent variables. So that means we're going to have 3 hypotheses. One is that the 2 independent variables interact with each other. So does the relationship between depression and treatment type differ for stage of change groups when controlling for stress? Or you could have said, is there an interaction between type of treatment and client stage of change on depression score when controlling for stress? So those, either one of those are fine to say. That would be the interaction. Then the next question is a main effect. Is there a main effect for treatment type on depression when controlling for stress? And then the third hypothesis, is there a main effect for client stage of change on depression when controlling for stress? So you can see all of that on the Word document that accompanies this. In my class, I often talk about how each arm can represent a variable, and then you can put up fingers. So you would be putting up a 2 on one arm and a 4 on the other, because this is a 2x4 ANCOVA. 2 independent variables. One has 2 levels per type of treatment. One has 4 levels for the client stage of change. It's a 2x4 ANCOVA. All right. So that gets us oriented. There are a couple of things that your textbook doesn't have. One is whether or not you have too many covariates. Because we only have one covariate, it's impossible to have too many covariates with only one. So we don't really need to do the Huitema formula, but you can see that in your textbook if you ever need that. Another one is if you had more than one covariate, you should just make sure that there's not a multicollinearity problem. If the covariates correlate with each other too high, that becomes a problem with the data as well. Next, we need to screen for missing data. I think you guys know my own way of doing this is just to sort ascending and descending on everything and just give it a look-see and see if anything comes up either with a missing or with a coded, like a 99 or something. And so far we got nothing, but there we go. There are 1, 2, 3, 4, 5 participants on stress score who we have missing data for. This data set has 661 participants, so we're going to leave them alone. The next thing we're going to do is to run a stem and leaf plot to see if we have outliers by group. So to do that, you click on Analyze, Descriptive Statistics, and Explore. When we get here, if you remember, you're going to want to put your dependent variable in the dependent list and your independent variables in the independent list. You don't do anything with your covariate. At this point, we're not paying attention to the covariate when we're looking for outliers. I'm going to click on Outliers under Statistics. And classically, go ahead and ask for a histogram and normality plots with tests. So we just get all possible things in here. Don't need to do anything under options and click OK. It's going to take the computer just a minute. And then I'm going to pop over to see that. Okay. So we are checking here for both outliers and skewness by group. So I've got the skewness in front of me, and you can see that the ACT group's skewness is negative 0.807. So we don't have a problem according to my own liberal version of skewness, meaning negative 1 to 1 is acceptable. For DBT, skewness is negative 0.530. So again, not a problem there either. If we had used the Kolmogorov-Smirnov test, we would have a problem with them. And it would be that we have a skewness problem in the negative, and it would have to be transformed. But in my class, I don't use that as the standard. These are just pictures. You can just kind of get to know your data and what the bell curve looks like. Then the next thing to look for are outliers by group. And we use stem and leaf plot for that for the Mertler textbook and for my class. This one you can look and see when it comes to ACT, right? And just the ACT group, it looks like we have 6 extremes that scored 2 or lower, right? That's our extremes, and the DBT group had none. So I'm going to go on back over and look for ACT group that the ACT group here that scored 2 or lower. And they're right here on the top for me already. Okay. Now to find them, you could have just sorted in ascending order on depression, and then make sure you only get ACT group, right? Because it told me I have ACT and only 2 people who scored a 2 on depression. So that's 1, 2, 3, 4, 5, 6. That's what the stem and leaf plot said I would find would be 6 of them. And I'm going to go ahead and delete them. All right. You can delete this. In my class, we often go ahead and delete everything but the ID number so that we're just kind of all the same from here on out. Okay. So that's what we have, but we haven't checked our stage of change groups yet. We have checked our ACT DBT, and we got rid of outliers for that, but we haven't looked at stage of change. So we're going to scroll on down here through all this, all these interesting stuff. And here we are, the 4 categories of stage of change. Okay. So that's what they are. And you can see skewness, negative 0.559 for the pre-contemplation group. Looks great. Negative 0.579 for the contemplation group. Also looks good. Negative 0.933 for the preparation group. Close, but good. And negative 0.703 for the action group. Looking good. So all 4 of those groups appear to be normal enough when using the negative 1 to 1 range of skewness to be acceptable. If we had used the Kolmogorov-Smirnov test, it would have been significant, and it says we should have transformed that. So here's our histograms just to kind of see, and you can kind of see the negative skew there. See how the tail runs a little more to the left. But again, according to our thing, it's not enough of a problem to need to transform it. Looking at outliers by group. Okay, so now this is just the pre-contemplation group. In the pre-contemplation group, there are no extremes on either end. No problem. In the contemplation group, no extremes on either end. In the preparation group, we have 2 who scored 2 or less. And in the action group, none. So this is telling me I should have two extremes who scored 2 or less on depression within the preparation group. So let me go on back to my data right here. And here we have the interesting thing. We've already gotten rid of all the 2s. And if we had kept it, we would have seen that a couple of them are preparation group ones. So what this is telling us to do is to delete the same exact data as what we've already deleted. So when we look at 2 different variables, sometimes they will have the same outliers for, for the type of treatment variable, which was the first one we looked at, will be the same outliers that they have for the client stage of change variable. And that's what we find here is just the number 2 essentially is an outlier. Okay. I am going to slow down here for a second, put those back, and go ahead and run it by z-scores. This is an alternative way to analyze your data. It's not the instructions in your homework, but it comes up often in my class, and that is to ignore the groups and only look at my continuous variables to see if I have outliers according to z-scores. So when that's the case, you are going to go just to analyze descriptive descriptives, and you're going to send over your continuous variables that are in the analysis. And you're going to click this little box down here that says save standardized values as variables. That is your z-score. Just click OK, because all we really need are z-scores here. And going on back, I now have some z-scores for both depression and stress. So I'm going to sort these and look and see. If you remember, there are different standards for this. Sometimes in my class, I've said -3 to 3 is the standard. Tabachnik and Fidel says something like 3.29. You can look that up. But your textbook also talks about if you have a sample of more than 100, you could use -4 to 4. We definitely have a sample larger than that. So let's just go ahead and look at it. So I did sort ascending, sort descending. It looks like on this, it would not count these 2s as outliers. Okay. Now I'm going to go ahead and remove them anyway, because we're using stem and leaf plot. But notice that stem and leaf plot was more strict than the z-score. And so just kind of knowing that is more likely to happen. We never have checked stress to see if there are outliers here. And in this case, if we would use 3, that would be an issue. But because your textbook says 4 is fine, we really should be fine on stress to not get rid of any of the stress scores as outliers. So this is just an addition to what your homework says, because I wanted you to be able to have this as instructions. Okay. So you should actually then, going back to the depression scores, sort, ascending from smallest to largest. All our 2s are gone. I got rid of those. Okay. And in your homework, it suggests going ahead and just kind of getting rid of everything, which is what I'm going to do. I'm just going to go ahead, make sure you don't delete more than you need to. 1, 2, 3, 4, 5, 6. Go ahead and get rid of them all. All right. And so those should be the right numbers there to match up. Okay. So we have gotten rid of our outliers. And we have looked at skewness. We have not looked at the skewness of stress yet, and we haven't looked at depression all on its own. So let's do that and run analyze descriptive statistics frequencies. And let me pull this. For some reason, I put it on my other screen. And we need to send over our continuous variables again, because you can only have skewness on continuous variables. And we need to ask it to give us skewness. Now, because I can't help it, I'm also going to ask for these other things. But skewness is really all you need. And then you're going to click OK. And we should get the output here. Right there. And if you look across, you'll see that the depression skewness all on its own is -0.516. So if I'm using the -1 to 1 range is acceptable, that's good. And the stress measure also looks good at 0.635 skewness value. Right. So these are various ways to look at issues of normality and outliers in your data set. So you can report that and move right along. Now, your textbook does not include equal sample sizes in its checklist in the back of the text or the chapter. So I recommend adding that in and just making sure you get a good look at it. We're going to see that when we run the ANCOVA here in just a minute. And so we'll get a chance to see what our numbers look like for equal sample sizes. All right. So I'll wait on that. The next thing I'm going to look at is linearity. So how do you run a linearity? For this, we only have two continuous variables in our analysis that we're doing, the dependent variable and the covariate. So because of that, I can do chart builder and I can click scatter dot over here. In the past, we've done this matrix, which allows you to put 3, 4, 5 variables in there, but we only have 2. So we can just do this if we want to, okay? And for this, I'm going to send over my continuous, looks like I can't stretch it. Oh, maybe I can to see it. There it goes. My continuous ones. So I'm going to put depression on the x-axis here. Hello, wake up. Did it work? Let's try that again. Depression on the x-axis here. Well, I gotta love it when that happens. Hold on, let's try that again. Looks like my computer is just glitching on me a little. Okay, I want a scatter dot. I'm gonna send it up. And then I'm gonna send over depression. There we go. And stress. And click OK. So I'm just looking for a scatter dot of depression and stress. So when you run that, you should get something that looks like this. Now, remember what we care about is that we don't want curvilinear relationships. So while we don't have a very tight hot dog or blimp here, we do kind of have a very fat blimp, right? Kind of like this, right? So we have a little bit less values down here and a little bit less up in this top left corner. And we definitely don't have something that you would consider a curve, right? So the data seems to kind of like run through here. So I know that this is kind of like reading tea leaves in some ways, but that's okay. What you're really looking for is that curve. And if we don't see a curve there, then you've passed it. You have a linear relationship between your dependent variable and covariate. So, okay. So after you've run that, we are going to do the hard one. The hard one is homogeneity of regression slopes. While we're running the regression slopes homogeneity test, we're also going to run homogeneity of variance because that's what your textbook does. So follow along with me while we run this test. Ready to go. You've done this before. General linear model, univariate. It's still univariate because we only have one dependent variable that we're dealing with. Our dependent variable is depression. Careful to never put z-scores in here. We never analyze z-scores. We always analyze the real data. Our covariate is stress, and our predictors are fixed factors, meaning they are either all of the things possible or they were specifically fixed and selected by our hypothesis. Okay. And then right on up here in model, we need to do something real weird. All right. We need to do something called build terms. For building terms, this is going to build out a model that's going to run. And what it's going to do is going to look at type of treatment. So send that one right on over. Send the client stage of change right on over. And send the stress score right on over. Then what you need to do is either hold down your shift key or hold down your control key, depending on what kind of computer you have, so that you highlight all 3 of these and send them over. Everything else stays the same. Nothing else needs to change. But what you should see there is the interaction of your 2 independent variables and your covariate, right? That's what you're actually looking for testing homogeneity of regression slopes. Hit continue. The other thing I said we were going to do is Levine's test. So under options, click on homogeneity test. And that's it. We're not going to do everything else at this point because we only want to test those things. This is not the real ANCOVA. This is the fake ANCOVA. This is the homogeneity test ANCOVA that we're about to run. So click OK. Excuse me. And we will see the data we need. And it's just a little bit of data here because I only clicked a few things in there. I didn't click everything we are going to do for the full ANCOVA. This actually gets us three things. One is we can start to see that unequal n issue. Now, we've got such a large data set that unequal n, not such a big deal. We're not too worried about it, but it looks pretty good. We don't have any group that only has like 10 people in it or something like that. I'm going to go on skip down to look at our homogeneity regression slopes test. This one is going to be within the ANCOVA analysis. You're going to look for the one that is the IV by covariate, or if you have two IVs by covariate interaction. So you can see that they are treatment, stage of change, and stress, all three in that row. Right? That's the data we're looking for to test homogeneity regression slopes. And it is telling me that the F is 0.53 and the p-value is 0.809. That is not significant, which means that we have passed the homogeneity of regression slopes assumption. This is a really important assumption because if we had not passed it, if this had been significant and less than 0.05, then we would need to drop the covariate from all future analyses. We wouldn't be able to include the covariate after all in our study. Okay. Your textbook has you go ahead and check Levine's test right now too. And that tells me that the F is 1.206 and the significance is 0.297. So that is definitely good. We have passed homogeneity of variance as well. Pretty little data set. It's all working out. We really only had a problem with a few outliers on the stem and leaf test. Everything else passed beautifully. So hopefully you've got all of that. You'll see in my instructions how to actually write up these things like F parentheses 7,642 and parentheses, equals 1.206, P equals 0.297. That's how you write Levine's test. So you see all of that in the write-up, okay, what it looks like. All right, we are officially done with all of our assumptions and everything's been passed. Because we passed homogeneity regression slopes, we get to keep the covariate. So we are going to run an ANCOVA now. So we're back up over here to analyze. Running an ANCOVA, click on univariate. Everything's here where we left it, but this is the most important thing. And often one or two students will forget to do this in the middle of a test and make me very sad for them. You need to click the model and go back to what we call full factorial. Full factorial means you're going to run the ANCOVA as a standard regular way. We're not doing it this weird special way to test an assumption anymore. We want to run a regular ANCOVA. So we've got to do full factorial, click OK. We also want to see our plots. And so I'm going to do both ways on this. Flip them so that I can see what it looks like either direction. And I'm going to run EM means, meaning I want all my mean scores. I want to be able to follow up on any F tests that are significant. If that door is open, then I can compare main effects right here. And we're going to need that on this because stage of change has 4 groups, remember. Type of treatment only has 2. It's easier to just send it over anyway. Stage of change has 4 groups, so we're going to need that compare main effects for that. And then for the interaction, that would be 2 times 4 or 8 groups. So we definitely need the interaction post hoc, which is this button right here. Compare simple main effects gets me the post hoc for the interaction. We adjusted a little bit for running so many analyses with the Bonferroni there, and we click continue. And then back over in options, we could turn homogeneity test off. I'll leave it on just so you can see, but we click continue and okay. And we give it a second and it should be giving us now our real ANCOVA. Sometimes it's helpful at this point to look here on the left. You can see this was your ANCOVA for running the assumptions test and just had that little bit. This is your full real ANCOVA. So starting here, you see it highlighted when I highlighted it. So there we have that. We've never looked at the unequal n for the interaction. We do have one group that only has 56 people in it. That's people who got DBT treatment and were in pre-contemplation stage. But still, 56 is pretty good. We start getting worried. People differ on this. If you have less than 15 or less than 10 people per group, they start to say maybe you really can't even look at the interaction at that point. Here's our Livian's test again. Note it's slightly different, but not too bad. Here's our real ANCOVA results. So we should have 3 tests here to look at. One is the interaction. Pay close attention. We just have independent variables here. Type of treatment, client stage of change. No covariate. We ran it right. This is the real ANCOVA, not the regression slopes one. The regression slopes one had the covariate sitting in there in the interaction to test it. This one is just the 2 independent variables. So we're going across here. We have an F value of 1.338 and a P value of 0.261. So it looks like our interaction is not significant and a very low partial eta squared. But when we look at our type of treatment and stage of change, our main effects all by themselves, ignoring each other, right? So they don't interact with each other, but they do have main effects all by themselves. So this is almost like 2 one-way ANCOVAs, but they are significant at the P less than 0.001 level. Now, because treatment only had 2 groups, we know now, based on this result, that the type of treatment was different. So we can go on down here and look and see which one had a higher depression score. And it looks like the ACT group had a higher depression score than the DBT group. Now, this is made up data, so who knows why that might be. Maybe there's some theory somewhere, but really this was just me putting data together that I thought might be interesting for you guys. It's fictional data. But you can see right here, here's your pairwise comparisons, but you don't really need them because ACT to DBT, you have a difference of 1.836 between their mean scores right there. And that is significant, but F-test already told us it was. Up here, you see this little A superscript and it tells you covariates are in the model evaluated. This is what lets you know that this is your adjusted mean score right here. So the adjusted mean score for the covariate is 14.89 and 13.06. Okay. Where do you find your raw mean scores? You got to scroll right back on up here to this one. So here we have the ACT one would be 15.13 and the DBT one total would be 13.02. So you would take those and put them in a table when you're presenting your results, both the raw and the adjusted for the covariate one. Okay. So that's the easy one because there's only 2 groups. So no problem. When you have 4 groups, here we have the main effects for the 4 categories of stage of change. That's the mean scores. Again, these are adjusted for covariate, and you would find the raw ones back up there at the top that I just showed you. But for this, we are going to have to do, let me put this in the middle here to see it, pairwise comparisons for all the groups with each other. So this says pre-contemplation compared to the other 3, contemplation compared to the other 3, preparation compared to the other 3, and action compared to the other 3. Notice that they're going to be the same forward as backwards. So for instance, preparation to action gives you a mean difference of 0.189, right? And it's not significant. But action to preparation, which is just this exact same thing backwards, gives you a difference of 0.189 negative, but that doesn't matter because it's just a different score. Same p-value, 1.000. I will make a note here. This is just like a leftover weird thing about SPSS. While they switched it to now say negative 0.001 whenever significance is low, they never switched it to the other end whenever it's basically perfect. So action and preparation scores are, terrible. But basically what they're saying is not significant. So if you ever get a 1 here, question the data. Probably Dr. Jen made them too similar to each other, but they're definitely not different from each other. That's definitely not less than 0.05. Okay. So you can just go down here and see, looks like pretty much everyone is significantly different from each other, except for two comparisons that you're doing. One is that the contemplation to action group are not different, and the preparation to action group are not different. Okay. So you'd be able to say that in your results section. Now, I'm going to do something illegal now. All right. I'm a rebel in the moment here. And this is the interaction. We shouldn't even look at the interaction. Remember that SPSS is going to give you all of the post hocs, whether or not it should give it to you, right? Whether or not the F test was significant. Back up here at the F test, which is our guiding light, it is not significant. So we shouldn't look at the interaction. Okay. Take that to heart. Make sure you fully understand and embrace that concept. However, I also need to teach you, if it had been significant, what would you do? You need to know how to read it. Okay. So we're going to read through these. One, always look for this little star. Look for the star like Disney. Treatment type times categories of stage of change. That's our two independent variables interacting with each other. Okay. This also gets us our mean scores here. ACT pre-contemplation, right? All the mean scores for the 8 groups are right here. Adjusted for the covariate. And then now it's going to do pairwise comparisons both ways. So what that means is it'll say, for just pre-contemplation participants, do we have a difference on ACT to DBT? Yes, 0.008. For just contemplations? Yes. For just preparations? Yes. For actions only? Yes. Okay. Don't let that fool you. Just because the pairwise comparisons turned out to be significant doesn't mean anything. That F test wasn't. The F test is more conservative. It's more strict. So you go with the more strict one. You go with the more conservative one, which is the F test. That's the global decision maker. So again, I know I'm saying this 10 times. I just don't want people to be misled. So here we had, if we had that F be significant, we would report all 8 groups are different from each other when you compare them this direction. Now we're going to compare them the other direction. So this is just looking at it, like look at all the ACT people and compare the 4 groups, and then all the DBT people and compare the 4 groups. So for that, here's ACT, and it compares pre-contemplation to the other 3. You can look there, all different. These 3, all different. These, yet again, similar to before, preparation and action, not significantly different. And action preparation, not significantly different. So that's for the people who got ACT. That's about half the sample got ACT, and we ran that for them to see what their differences are. Okay, so we've got just one group, not different. Everybody else is. Okay, now take the other half of the sample who got DBT. Do they differ by stage of change? And I'm going to run down here. Looks good, looks good, looks good, looks good. There we go. All right, contemplation to preparation, not significant. Contemplation to action, also not significant. Preparation to contemplation, that's the same thing backwards. Preparation to action, not significant. You may end up needing to kind of like write this out longhand. This one, action to contemplation and action to preparation, should be replicated. Like we've already done this. Preparation to action here, action to preparation there, contemplation to action there, action to contemplation there. See how it's just duplicate information. Okay. So when presenting this, you'd have a little bit of a complex story to tell to the reader about when you see it. And you can kind of see these things sitting here, right? That's the interaction. Even though the lines cross, the F test says those aren't significantly different enough that it kind of doesn't matter. So here we are from the beginning. And then this is it looking at the other direction with the 4 stages here and the ACT line and the DBT line as separate lines. So it just kind of depends on how you want to look at it for your data. Okay. So I'm going to now move my Word document over here because we have run everything. And in your Word document, you got all this, right? So you guys can read it. This is exactly what I just covered. It walks you through, and it talks about we shouldn't look at that. It's just for practice. But so we walk through looking at it for the sake of practice. And then this gives you an exemplar result section. and walks through all the assumptions, the main F tests, pairwise comparisons, that sort of thing. And then you have your table with your adjusted mean scores and unadjusted ones. These are for the main effects only. If we had a interaction, we'd have to do like a whole fill in the blank thing for that. So here's our, this is the only one that we would really need because those are the F tests that turned up to be significant. So if that gets you a sense of your data, and then that's your pictures that we also brought over. I just brought one of them over to see. Okay, I hope all of this is helpful to you and that you are able to find your way through running an ANCOVA and that this is helpful for your work. All the best to you.